to have you all here. Particularly delighted to welcome Lillian Martin, who's visiting us at the moment, but all of you are extremely welcome. Today we don't have Andrew Pollard as the speaker, as was listed. He is in Geneva at a WHO meeting working on an issue which I'm sure is on all of our minds, not least since Peter Piot's brilliant talk last week, which is Ebola and the Ebola vaccine. But we do have Dr. Matthew Snape, and I'm really delighted that Matthew has been able to step in at very late notice to take Andrew's place. So thank you, Matthew. It's very good of you, and no doubt you'll give us a hint of what Andrew's up to as well in trying to find a vaccine for Ebola, and maybe if people have questions on that, you'd be prepared to take them. So Matthew is a consultant up at the Radcliffe Hospital. He's a consultant in vaccinology and general pediatrics. He's also an honorary senior clinical lecturer and is a practitioner within the National Health in Child Vaccinology and Pediatrics. He hails from Melbourne, where he was at the Royal Children's Hospital. He's worked very much on the front line in the intensive care unit at St Mary's Hospital, London, where, of course, one of our royals was born. He has been there on the front line, and he's cared for children who have all sorts of illnesses arising from immune issues. He's been at the Oxford Vaccine Group, working particularly on hepatitis B, influenza, pneumococcal, is that what it is? And meningococcal. He has co-authored over 50 articles in many esteemed journals like the Journal of the American Medical Association, the British Medical Journal, and Lancet. And he is someone who we're absolutely delighted to have. Thank you, Matthew. The floor is yours.
Thanks very much, Ian. And thank you for inviting me to speak at 2 days' notice. But there we are. It's always good to have a challenge. So I work up at the Children's Hospital. I'm one of the paediatricians, the general paediatricians up at the Children's Hospital. Half my time is spent looking after sick children there, and half of my time is spent trying to stop them getting sick in the first place through my research in vaccines and so on. I'm seeing that I'm not being heard by some people. Can you hear me now? Better? Up? I have volume control at the back. There we go. Okay, thank you. So this is the group that I work with when I'm doing vaccine research, which is the Oxford Vaccine Group. The staff of about 70 of us. I'm actually not in that photo. I think I was running a clinic that day. This is the chap you were going to get, Andy Pollard. He's the director of the Oxford Vaccine Group. The vaccine group's entering its 20th year this year, so anniversary later on. And I've been with the vaccine group for myself for 11 years now. And I'm a general paediatric trainee. Why did I get in? As a general paediatric trainee, I entered the Oxford Vaccine Group. Why was I attracted to vaccines? It was because of graphs like this, these extraordinary results that you can achieve from an intervention like this. This is, if we look at this clearly, this is the 1980 measles. Over 2.5 million children dying every year from measles. And the effect of an effective vaccine being introduced and being introduced properly, as you can see the immunization rates coming up here, and this is running up to 2005, where you've had this dramatic reduction in disease. Down here to 300,000 or so, therefore, a year. That's still far too many, but it's an extraordinary reduction. And this is another way of looking at this. This is actually over the last decade where there has been further progress in measles prevention, where, and this figure at the top here is the cumulative number of deaths prevented by measles immunization over the last decade. So up to 13.8 million deaths prevented. So what you've got down here on the bottom line, this is the incidence currently heading down to 200,000 or lower. And this is the incidence as it would have been without any measles immunization. This is such an effective intervention that can be made. And clearly, prevention here is so much better than treatment. I could be showing you hundreds of graphs like this. This is another one. This is neonatal tetanus. Tetanus, neonates are especially vulnerable to tetanus due to exposure during birth and their immature immune systems, where they get paralysis. In 1980, over 1 million children, neonates dying every year from neonatal tetanus. And to prevent this, the WHO has had a campaign of immunising pregnant women in countries at risk from neonatal tetanus. And that, along with hygiene measures, has resulted in, again, this dramatic reduction where it's now down to 100,000 as the uptake of the vaccine in pregnancy has gone up. So that's why I've always been interested in immunisation and attracted to that. You can't give an immunisation by law. I think you can't give an immunisation lecture without mentioning that smallpox has been eradicated. However, did you also know there are 3 types of polio viruses, and that one of those has actually been eradicated also, so it has been declared eradicated. This is the type of awful picture, I apologise for that. This is the type of children that I was looking after at St Mary's Intensive Care Unit where, with meningococcal disease. And I'm going to talk about what that is, but that's, for me, what drove me into wanting to work with vaccine research to develop a vaccine against meningococcal disease. I've given you some graphs of what's been happening globally over the last decade or more, but it's also been a very exciting time locally for immunisations, and this is obviously something that's relevant to every child that's born in the UK. Every child will be getting these vaccines as they go along. And this is the schedule as it was just in 2006, where, and this, with the exception of MenC that had been introduced around 2000, apart from that, it actually stayed pretty much the same for a decade or more prior to that. Vaccines were seen as something that was really not going anywhere at a great rate. But in the 8 years since then, there's been a huge number of introductions into the UK schedule to try and improve the health of UK children. Pneumococcal is one of them. This is a bacteria that can cause pneumonia, meningitis, septicemia. Rotavirus, a common cause of gastroenteritis, which was introduced. Pneumococcal was introduced in 2006 with an updated version introduced in 2010. Rotavirus was introduced last year. We've got strengthening of the meningitis C immunisation campaign to prevent meningitis, a major cause of meningitis. We've had, a few years ago now, the human papillomavirus introduced to prevent, vaccine introduced to prevent cervical cancer. And more recently, last winter and again this winter, and it will be going on, there's a plan to immunise all children 2 to 4 years of age with the intranasal influenza vaccine. So even in the UK, where we have generally good health standards, there's an important role for immunisation to play and changes there. And we've been, within the vaccine group, we've been involved in the introduction of many of these vaccines, the clinical trials that have shown the immunogenicity and side effect profile of vaccines in the UK. So this is the title that we had. What's next? Well, one of the things that's going to be next, we hope, is the vaccine against meningitis B. And I'm going to take a step back now. And there's the possibility that this vaccine will be introduced into the UK. And I'm going to take a step back to explain what is meningitis and why there's meningitis C, meningitis B, meningitis A. You'll be hearing all sorts of different terms thrown around. Meningitis just means inflammation of the lining of the brain. And just like arthritis means inflammation of a joint. And just like arthritis, there can be many different causes of meningitis. As it happens, most of those in children are infective. So there can either be a virus or bacteria, are the 2 most common. You can also have fungal meningitis. Viral meningitis, nasty in some forms, but usually more benign. And the one that people dread is bacterial meningitis. The 3 major causes beyond the neonatal period in the UK in children are Hib, Haemophilus influenza B. The vaccine was introduced against that in 1993, and we do not see it anymore. Pneumococcus, as I mentioned before, this vaccine for children was introduced in 2006, and this bacteria also causes pneumonia and septicemia. This vaccine does not cover all forms of pneumococcus. There has been a dramatic reduction, but we still do see some of this. And then there's meningococcus, which is the bacteria looks like this. And meningococcus can cause not only meningitis, and many of you will be familiar with the type of symptoms that we talk about for meningitis: neck stiffness, bright lights hurting, headache, fever. They're actually more common in older children rather than younger ones, as it happens. In young children, it's very non-specific, just irritability. It can not only cause that, but also can infect around the whole bloodstream. So not be contained just to the nervous system, but spread through the whole bloodstream. And actually acutely, your prognosis for this is much worse. This can rapidly spread to bloodstream infection, rapidly spread to multi-organ failure through septicemia, and death within hours, unfortunately. This is the test, this is the disease for which you do the infamous glass test, where it creates a distinctive rash because of bleeding into the skin. And so that's why even when you press on it, it doesn't go away. And that's the glass test that the vast majority of parents will be familiar with. And this is a dreadful illness that causes death in the UK, still at around 5 to 10% of children, and long-term disability in up to 20% of survivors, including limb loss. And we'll still see children with this at the hospital. So now I talked about the meningitis, A, B, C, etc. Why does this alphabet come from? Well, there are 6 main types of meningitis, of meningococcus that cause disease in humans. 13 types altogether, 6 in humans, A, B, C, W, X, Y. And what you can see here is that in Europe, it's almost all about serogroup B. There have been vaccines available against A, C, W, and Y for at least getting on to 10 years now that have been able to be used. But B has been, for technical reasons, it's a very much more challenging vaccine. All these vaccines are based on the sugar coating of the bacteria, whereas for B, that doesn't work. It's a polysaccharide coating of the bacteria. For B, that does not work. You have to go to the proteins under it. It's been very technically challenging. That's why we were left with this causing so much disease and no vaccine to prevent it. In 1999, we introduced the serogroup C vaccine, around 1999-2000, and as a result, along the black line here, you can see that the disease went away. I think it was 67 deaths from this disease in 2005, 2 years later, and has gone away since. Extremely successful. But serogroup B has gone on every year, causing approximately 1,000 cases a year in England and Wales. About 5 to 10% of those are dying. And the age group that's most affected are in the under 1-year-olds, 2-year-olds. You will be aware, perhaps, that there is also a second peak in university-age students, and that's where you can get outbreaks of this disease in colleges. This is when you hear meningitis outbreaks in university, it's almost always meningococcus and almost always serogroup B. So what's been going on, the work that I've been involved with over the last 10 years, since 2006, was a collaboration with Novartis Vaccines, one of the pharmaceutical companies, and they're developing the vaccine. And we gave this first dose of this vaccine to any child anywhere in the world in 2006. We've been doing clinical trials then, enrolling over 1,000 children and young adults to this vaccine, many of whom took part in follow-on studies. And this vaccine, as I mentioned earlier, could not be developed from just the standard approach we take with this type of bacteria of taking the coating outside the bacteria. And there had been decades of work to try and develop a vaccine against this, which had been broadly unsuccessful. And the novel approach was taken here, and so instead of starting with the organism, looking for vaccine targets from the organism itself, it started with the genome of the organism. So looking at the genetic code and expressing the proteins that genetic code coded for, and then assessing those proteins as vaccine targets. And using that, they developed a novel vaccine. This vaccine, after clinical trials beginning in 2006, using the data from those, was actually licensed in started in 2006, was licensed in 2012, which is a very exciting moment for us. But there's a bit of a problem. Firstly, this vaccine actually doesn't cover 100% of the serogroup B disease, not as much as you'd want it to. Best guess is around 75% in England and Wales, up to possibly into the 80%. And actually, for reasons that we don't understand, the disease has been going away, which is nothing but good news. But it has been declining. This might even relate to the smoking ban, because we know that in pubs, because we know that carriage of this organism in the throat clearly relates to smoking. It also relates to number of kissing partners and attendance at pubs and drinking. I can't understand why it happens in university students myself. From 2002, where we were getting around 1,200 cases of this disease, we've gone down now to around 600 cases. And this is nothing but good news, but it actually creates a bit of dilemma. Do we actually need this vaccine now? That's why there's a could there, because this is being looked at. And I'm not sure how much you're aware of how these decisions are made, but it's a long and involved process as to how to decide whether to introduce a vaccine into the UK schedule or not. You'll have heard of NICE, the National Institute for Clinical Excellence, which decides whether a new cancer drug is introduced. And that's based, and all the other medications. That's always based on a cost-effective analysis. You'll have heard of this on the news. It wasn't cost-effective. And what they use to base that on is something called a quality-adjusted life year, which is a kind of one quality-adjusted life year is 1 year in perfect health. If you have 1 year with a disability, then you have less than 100%, less than one quality. And so, as I said, it's analogous to NICE. If you're interested, one of your qualities is worth £20,000. That's the threshold. So that's what, to be cost effective, an intervention needs to cost less than £20,000 per quality adjusted life year gained. It's a health economist argument. The challenge has been actually with this reduced rate and with a vaccine that's less than 100% effective, to be cost effective, the publication that came out just 2 weeks ago came up with the figure that this vaccine will be cost effective only if we buy it at £3 to £7 per dose. The manufacturer's list price is £75 a dose. Now, I'm not giving a talk about health economics. I'm not a health economist, but this is a challenge. This has been a very difficult vaccine to manufacture, and this is a negotiation that's going on now between the Department of Health and the vaccine manufacturer to see if they can come up with something that will be both compensate for the work that's gone into developing this vaccine, but also be reasonable for the taxpayer. And this is very much an uncertain thing how that's going to come down. So that's one new vaccine that might be coming in next year. There's been another story in the UK over the last 2 years, which has been very upsetting for paediatricians who have been seeing children like this turning up at the emergency department and in the intensive care units in 2012. This is unlike tetanus, unlike diphtheria, which I've never seen a case of diphtheria, and measles even, now very rare. Whooping cough, or pertussis, is still very much around, and it comes in waves, and we saw a wave in 2012. This is probably due to immunity from childhood waning, and adults can become infected even if they've been immunised, and then it's very easily spread because it's a disease that causes coughing. It causes paroxysms of coughing, and if you get that when you're an adult, it's a nuisance, and you can actually fracture ribs and so on. If you get that as a neonate, then it's life-threatening because the coughing can go to such an extent that they lose the ability to breathe. They can't take the whoop as they inhale after a long coughing spell. That's where it gets its name. And it's the children that were dying were too young to be immunised. These babies 3 months or under. We immunise at 2, 3 and 4 months of age. So the UK took a really quite a novel approach and responded to this, whereas the decisions about the vaccine I was just talking about, meningitis B, have rolled on over years. Within 6 weeks, the decision was made, we need to do something about this. And what they did was to immunise not babies, but the mothers in pregnancy. So introduced this vaccine to pregnant women, and it was a standard preschool booster that includes not just pertussis, that's whooping cough, but diphtheria, tetanus, and inactivated polio. And that is intention. If you immunise the mother, she'll develop high antibody levels, and those antibodies will cross the placenta, and the baby will be born with high antibody levels against pertussis. It has to be said, there was not a great deal of evidence that this was going to work. We knew that babies born to mothers that had the vaccine had higher antibody levels, but beyond that we didn't really know very much. But it does work. First thing to say was the acceptance was very high for a new intervention, and there is some scepticism about immunising pregnant women, despite the fact I showed you at the beginning of the neonatal tetanus campaign. That's all about immunising the pregnant mothers. But it was uncertain how acceptable that would be in the UK. But actually uptake has been up to 60%. You can see along here. This is a surveillance on some GP centres. And it's around 60%. And this graph shows what's been happening since then. So on this y-axis, you have the incidence per 100,000 per year for children less than 1 year of age. And on this axis, it's for people over 1 year of age. And the blue line is the under 1 year of age, and this massive increase and this massive drop after the campaign to immunise pregnant women. Now, you also saw a decline in, what's the dark blue, 1 to 9 year olds. That was nothing to do with them, the pregnant women being immunised. Clearly, this was part of a natural cycle. But the decline was more steep in this older age group, and when they actually looked at the effectiveness of this campaign, comparing the cases that then occurred, looking at the chances there, whether or not their mother had been immunised, compared with the general population, they could calculate this intervention was about 90% effective. So sometimes it's not about developing new vaccines, it's about using the vaccines that you already have better. And that's many of the changes with the immunisation schedule relate to that also. Okay, so that's a little bit background from in local, the UK schedule, what's been going on. But clearly, the greatest burden of disease is not in the UK. We're very fortunate. The greatest burden of disease is more globally. This is from a statement from a publication called the Global Vaccine Action Plan that I'll come back to later. And we're used to bad news stories, and we have plenty of bad news stories every day. And clearly the fact that 7.6 million children are dying each year under 5 years of age is terrible and is a bad news story. But then if you compare it to where we were 10 years before that, where 9.6 million children were dying every year, there has clearly been great progress. There's 2 million children less under 5 years of age dying every year. And this has, obviously there's no one cause for this, but part of it is the improved immunisation uptake and campaigns. Just to go backwards a little bit, if we take us back to 1980, remember when I said 2.5 million children each year were dying from measles? Perhaps that's not surprising when you look at the overall, this is actually for diphtheria, tetanus and pertussis vaccines, but the uptake globally was just an inch above 10%. I find that extraordinary. And then that over the next decade, there was this extraordinary increase in uptake to around 75% by 1990, within a decade. This program was called the Extended Program for Immunisation, EPI, backed by the WHO, a big push. And you can see the huge amount of global variation depending if you're in sub-Saharan Africa in the blue here versus industrialised countries in the red. Dramatic progress through the 1980s to 1990. And then then it stalled. There's a kind of flatlining or even a dropping off then of immunisation uptake. Lost momentum. So at the turn of the millennium, there was a whole new push for this, and many of you will be aware of this. Of course, you have to mention at this point the Bill and Melinda Gates Foundation, who are a massive funder of this, along with Gavi, which they're the major funder for again, and all the other organisations, and many more that you can see on this slide here. Till they've got to the point where things are better. There's still room for improvement, but they are better. In 2013, this is WHO figures, diphtheria, polio, measles, around 84%. Hepatitis B, which is immunisation to prevent long-term liver cancer, 81%. I'll come on to these in just a moment. So, the number of deaths caused by these traditionally vaccine-preventable diseases that you can see listed there has fallen from about 0.9 million in 2000 to 0.4 million in 2010. There has been progress. What are children dying for now? I hope you can see this reasonably well. This is a paper published in The Lancet in 2010 that took from multiple different sources of information. It's a massive paper looking at what children are dying from today, 2010. And this, firstly, I've left the neonatal period behind here. There's a whole other story. But from children 28 days to 1 year of life, they're dying actually from pneumonia, lower respiratory tract infections. They're dying from diarrheal diseases. We'll come on to some of the specifics. They're certainly dying from malaria. There's no surprise there. And there's meningitis and encephalitis. It's looking at this, just how much of it is infectious diseases that could be potentially vaccine preventable. So if we look at which ones are vaccine preventable out of this, potential to cover most of those, certainly whooping cough, certainly measles, influenza we have vaccines for. WHO recommends global use of influenza vaccines. Pneumonia, many of those will be caused by this pneumococcal bacteria that I've been talking about. Hib, there's a vaccine for Hib. Rotavirus, there's a vaccine for rotavirus that's been introduced into the UK last year and is with great effect. So many of these are vaccine preventable that children are still dying from, and I'm just going to go through some of these. The same applies for children 1 to 4 years of age, as you can see here. And so because we're not there yet, there's been announced that the coming decade is the decade of vaccines. To take it to the next step, the collaboration from Bill and Melinda Gates, all the other groups, organisations that you can see there with the backing of the WHO. And they've set various targets. I'm not going to go through all these targets. One of them is, and you might have heard of this, by 2015 to interrupt wild polio virus transmission globally and to eradicate by 2018. This is a target that's been pushed back and back and back and back, unfortunately. This is a target that has been incredibly difficult to meet, partly because of disruptions to polio immunisation programs in war-torn areas or countries that are refusing the vaccine with unfortunate effects. Some are saying that measles should have been the one that should have been targeted for eradication. It's a very stable virus with no animal reservoir or any reservoir other than humans. It lends itself very much to eradication, and we may be on path for that. So there is a target for eradication or elimination, which is not eradication, but elimination in at least 5 WHO regions by 2020. We're moving down that target. And it talks about uptake, immunisation, targets. I won't go through all of these, but this is where the action is in terms of global policy for vaccines. Quickly, Gavi, which is the Vaccine Alliance, which was launched in 2000. Just to mention, the major funders are Bill and Melinda Gates. UK is not far behind, actually, and it does itself proud with regard to funding vaccines in this area. What Gavi does is it tries to target immunisation, obviously in countries that need it, but countries that are also ready for it. Countries that have made a commitment to immunisation, that once the Gavi funding is withdrawn, they'll maintain the immunisation program and have the capability to do so. So it's all about building the country's capability and making them able to deliver the vaccines. So you can see that the pentavalent vaccine, this is a diphtheria, tetanus, pertussis, polio and Hib vaccine. 68 countries are getting Gavi support for this to try and introduce it. This is the number of countries that has been going up. These are their goals and matching it against the goals for this. I mentioned rotavirus earlier. One of the key goals of Gavi is to shorten the delay from use of these vaccines in industrialised countries, in the wealthy countries, to getting them into the countries that need it most. Rotavirus is used now by many developed countries, introduced into the UK last year, but where the deaths are happening, not surprisingly, is in the poorer countries, countries that need it most, where they haven't until a vaccine. And with previous vaccines like hepatitis B, the delay to getting them into poorer countries has been decades, 10, 20 years, and this aiming to shrink that down to 1 to 2 years. And there, with some success, as you can see here, it is getting into those countries. Pneumococcal, again, similar story, it is getting in earlier. And the uptake, there's still a lot of work to be done here. You can see it's actually within those countries where they're using it to get a full immunisation course. The figures are not high. Okay, I'm going to step sideways now to a real success story that's happened over the last few years about meningitis. And we're back to the meningitis alphabet, I'm afraid. And now we're talking about meningitis A. And you can see here, I hope, possibly it's quite faint, but in Africa, unlike Europe, where it's all meningitis B, in Africa it's meningitis A. It's causing vast amount of disease. And this is mostly happening in what's called the meningitis belt. Just in sub-Saharan Africa, just sub-Saharan is the meningitis belt, where they have massive epidemics. It's seasonal, so it comes on predictably at the same time of year. And these epidemics can be enormous, from December to June. And largest one recently was in 1996. In a few weeks, 150,000 cases, and you can see the deaths. Now, unlike the Men B vaccine that I was talking about, the Men A vaccine was not technically tricky. There was a clear knowledge of what kind of vaccine you needed to make based on the polysaccharide capsule I was talking about earlier. But the challenge was getting someone to make it. There's always been, how do the companies make money out of vaccines? They need to invest in it. To recoup their investment, they need a commitment to purchase millions of doses, preferably hundreds of millions of doses, so that they will invest and can then get their money back. And that's what the Gavi Foundation has been able to do for many vaccines. As it happens, this particular project was led by the meningitis vaccine project, which is funded by the WHO and PATH, that you can see there. And their goal was to get a vaccine for this region at a cost of 50 cents per dose to make it affordable. The vaccine manufacturers in the standard industrialized countries weren't able to meet that price. So they took an entirely novel approach, which has really got large implications for future vaccine development, that they went to a middle-income country of India. And the company, the Serum Institute of India, there was technology transfer, there was first world technology that was transferred there to say, make this vaccine at this price, and they've done that with extraordinary success. This vaccine was introduced in December 2010 in Burkina Faso, initially in 3 countries, and look at these figures. So in 9 days, 11 million people immunized with this vaccine. And 153 million doses have been administered since December 2010 across 11 countries, targeting 1 to 29-year-olds. And the disease has gone away. So you can see what the previous incidence was. This is a weekly total at this peak period in 2009, 8,000 cases a week. And no person who's received this vaccine has developed meningitis A since then. So a great success story. That's an observational study, and obviously that's prone to year-by-year variation, so a more formal study was conducted and published in The Lancet, where they introduced the vaccine into some regions and not others, and found that there was 94% effectiveness for this vaccine. It has prevented a huge number of cases. Okay, so clearly we can't talk about childhood immunization or childhood deaths and how to prevent them without talking about malaria. And this is challenging. This is the report by the WHO at the end of last year, which again has some good news. And so, this is a talk about immunizations, but it's not always about immunizations. In the absence of an effective vaccine, it has been possible to have a 48% decline in malaria deaths in children under 5 years of age over the last 12 years. And that's due to insect control, mosquito control measures. It's due to impregnated bed nets with pesticides. And obviously better diagnostics and better treatment. So you can have a major impact in the absence of a vaccine. But there are still 207 million cases globally, with approximately over 600,000 deaths. 90% of these deaths occur in sub-Saharan Africa, and 77% occur in children under 5. So if we could have a vaccine, this would be wonderful. This is a review article which has this table outlining where we're up to. Vaccine developments, like all drugs, go in phases. You start at a small phase 1 study, build up to a slightly larger phase 2, and then to a phase 3, which is usually about efficacy in the trial, in the field. So doing a study where you look to see if it actually works in the population you're interested in. You can see there are many vaccines at phase 2 or at phase 1, and one that has got to phase 3 that we'll talk about in just a minute. A lot of the work that's been done in this has been done in Oxford by Adrian Hill in particular, who's got 3 candidates on this list in development. You'll thank me. We're not going to go into the malaria life cycle. Just to say, there are many different bits of the life cycle that can be targeted, and vaccines are in development, looking at either trying to block transmission in the mosquito or trying to stop the blood-borne phases because it infects erythrocytes or red blood cells, or trying to stop it before it gets into the red blood cells. And this is where this vaccine that's the most advanced is working, is targeting. And there was this study published in 2013 of 6,500 infants aged 5 to 12 weeks with this study, with this vaccine in Africa, in the countries that you can see here. Did it work? You'll have seen on the news. Yes, it did work. So this is efficacy of 31%. So this is looking at the cumulative incidence. Looking, if you were in the red, you got the control. If you're in the black, you got the vaccine, the active vaccine. So clearly a lot of the children in the black getting the vaccine, you've got about 30 per 100,000. 30%, 30% did get malaria, compared to around 40% who got the vaccine. There's a reduction of around 31% and a reduction against severe disease of around 36%. This is a vaccine, I should have said, which has been developed by GSK. So this is the leading candidate. And if you can prevent 36% of severe malaria, where you're having, what was the figures? 200. We've got 207 million cases. That is a good thing. If you can prevent a third of these deaths, that would clearly be a good thing. But whether it's good enough is the big question. So there's larger scales now. We're now going into the larger studies of over 15,000 children seen in those 7 countries that you can see there. And this is the WHO will be receiving that data. This is from the WHO website, that they'll be receiving the data very shortly to make decisions about what's going to be happening, which may occur in 2015. The WHO have got 1 or 2 other things on their plate at the moment, but that will be part of it. Okay, briefly now, tuberculosis. It's up here. Not a major cause of death in 1 to 4-year-olds. Not a major cause. It is still hundreds of thousands of children we're talking about here in percentage. Perhaps not as quite high as some of the others. And you'll be saying, but we've got a vaccine against tuberculosis. What have we been talking about? Many of you will receive the BCG vaccine. It's not used routinely in infants now, but has been previously, and it's one of the most widely used vaccines in the world. The problem with with BCG, it's a live vaccine that's given injected in babies in the first week or 2 of life usually. And it's got proven effectiveness against 2 forms of TB. Miliary TB, which is TB that spreads through the whole body, overwhelms the child, more common in neonates and infants. And TB meningitis, again more common in neonates and infants. The efficacy of this BCG vaccine against classic pulmonary TB, where it affects the lungs, and that you recognise from the consumptive, if you like, is very variable. And strangely appears, there's a study that shows, well, it's well known to appear with latitude. The further away from the equator you are, the more effective the vaccine appears to be against pulmonary TB. So it's variable. So certainly it's not the full answer, and there are efforts ongoing to develop a new vaccine to build on the BCG program. And again, Oxford's been very active in this. Helen McShane has been working as one of the within the Jenner group, Jenner Institute, on a vaccine, the modified vaccinia ankara. This is a virus that is then modified to express an antigen, a key antigen of TB, which was then studied in over 2,000 South African infants. And you'll get used to this. You've got used to this type of graph now, that you're comparing the blue line placebo versus red to look at the cumulative incidence, and unfortunately there was no signs of any efficacy. Didn't replicate the encouraging immunogenicity data that had been present in earlier trials. So this one does not appear to work. This was the most advanced additional vaccine for TB. There are many other candidates that are still going forward, so that's an very active area of research still. Okay. I'm going to now take a step sideways to something different. We've been talking about global diseases, and I think there's already a theme here of saying that you can have an impact globally while acting locally or studying locally. Because this is a study that we're involved with in the vaccine group, looking at typhoid and paratyphoid. 1.5% of deaths in children, more commonly causing disease in adults, and you can see the number of million cases here in the countries that we see here, with a mortality uncertain, but in the several 100,000. You'll say there's a vaccine against typhoid. I'm sure I had the vaccine against typhoid when I went to Africa. There are vaccines against typhoid. Again, they're actually based on the polysaccharide coating, the sugar coating. They don't work in children under 2 years of age, and even in adults their effectiveness is about 70%. Room for improvement, not brilliant. And there is also a live oral form, which again has effectiveness around 70%, so not as good as it could be, and this is still seen as an important area for further improvement. So what we've been doing at the Oxford Vaccine Group, and Andy Pollard has been leading on this, is develop a human challenge model, which is exactly what it sounds like. We have volunteers who come forward who are infected in a controlled manner, and then is used as a model for vaccine to help test new vaccines. So this is a paper that we've published on this model, which is in Clinical Infectious Diseases from earlier this year. So we have volunteers who take part. We determined the dose at which you get a 65% strike rate, infection rate, and 10 to the 4 unit colony forming units, as you can see there. And of course, everybody is treated. The reason we can do this is typhoid can be a serious infection if it's left untreated. But if you pick it up early and treat with an effective course of just oral antibiotics, the outcomes are very, very good. The risk is minimal. And so, hence, we can actually go forward with this with healthy volunteers. And so with this model now, we know that we can generate predictably an infection rate of about 2/3 in healthy volunteers. So the next step is then to test that in vaccine trials, to give the vaccine to some of the volunteers, give a placebo to some volunteers, or a control vaccine. That's exactly what we've done, which we'll come on to. Firstly, we've monitored very closely. So this volunteer didn't get typhoid. This volunteer's temperature went along, didn't come up in the blood cultures or anything else like that. There were no marks of typhoid. This participant did get typhoid, and you can see that we could monitor their temperature at the time their blood cultures became positive and their stool became positive for typhoid. Very careful monitoring, and further very clever and very interesting work looking at gene expression around this and what's going on, how the immune system is responding to typhoid during this. It allows very close monitoring from that point of view. So as I said, the next step is then to test this in studies. So we have a study where you're either getting placebo or an investigational vaccine here, or a licensed vaccine, and you can look at the success or otherwise of those vaccine. And this stops you going on to the massive clinical trials. The alternative to this is to doing your clinical trial of 5,000 people and then finding whether or not your vaccine works, and the risks in that, of course, are huge. Instead, you can test it on 100 people and see if your vaccine works or not before you go further. So it's been attracting a lot of interest and a lot of funding from Wellcome Trust and others. I wasn't going to get out of here without talking about Ebola, so I have a drink of water. This is happening in the building where I work. It's not run by the Oxford Vaccine Group, it's run by Adrian Hill's group, the Jenner group. And this is hugely important and been hugely noteworthy. So it's been recruiting now for about 4 weeks. This is a vaccine trial. It's going to enroll 60 people, 20 at different dosages. So low dose then for 20, medium dose for 20, higher dose for 20. This is using a lot of those candidates, like the TB vaccine candidate we talked about, we're using what's called a vector. So in this one we're using a virus. It's a virus that doesn't cause symptoms. It's a live virus. It doesn't cause symptoms. Chimpanzee adenovirus, which is introduced, which we won't have immunity to. And that's modified, so it inserts a gene that expresses a key target protein for the Ebola virus. So that's inserted. Oh, that's not how you spell target. Not Zaire. Oh goodness. Okay. Okay. You get what I mean. Coding for the Ebola Zaire target. Did I mention I had 2 days to prepare this? Target antigen inserted into the virus. And so that virus then codes for that protein. So it's immunized and taken up by the body, and it will code for the protein, and then the body mounts an immune response, which we hopefully protective. I don't have the results for this any more than you do. I know that it's being enrolled for at the moment, and there's a lot of interest in what's happening, and they've had a fantastic response for volunteers. They have all the volunteers they need and could do this study many times over if they needed to in terms of the volunteers. So it's been a great response. This vaccine was developed initially by Kairos, which has been subsequently purchased by GSK and is Wellcome Trust funded, and is being trialled both in Oxford and importantly in Mali as well with Adrian Hill. This is where it's being done, which is at the Churchill Hospital, which is where I work. My office is down here somewhere, and they're being challenged here. And it doesn't have any live Ebola virus, obviously, so it's entirely safe from that point of view. And I think when this was started, when this was planned, it was fast-tracked, and this is a real credit. We did a similar thing for the swine flu vaccine when this came through, that we got expedited approvals for ethics and for MHRA approval for clinical trials, so the system can be flexible when needed. So Adrian was able to get this study up and running very quickly. And I think when originally the idea would be, well, I think you'll be aware that this vaccine has been in development for quite a decade now, really. It's been there ready to be developed if people wanted it. A few Americans get sick and lo and behold, we need a vaccine now. That's overstating, and that's unfair. Obviously this work was going on even before it had spread to America or Europe, but still. Now, so it's now going through rapidly, And I think there was a feeling that, it'll be great to have it ready for the next time. Increasingly, it looks like it might well have a role here. We don't know the immunogenicity results, let alone, so when I say immunogenicity, that's looking at the antibody levels or the immune response. We don't have those results, let alone any actual efficacy study to show that it actually does definitely prevent disease. So it's important not to jump the gun here, but it is interesting, this headline from yesterday, I think, from The Guardian, and from a WHO statement, looking at the vaccine tests in Africa by January to roll it out, and it's thought that they might well use this initially in healthcare workers because for obvious reasons. The serum they're talking about here, this is a serum of survivors with antibodies that can then be used as a treatment rather than prevention for this virus. Okay, so we'll leave it there. I'm sure you'll have some questions, and I'm happy to take those.
Thank you very much, Matthew, for what was an extremely illuminating and also clear talk. I know it's difficult to explain to non-specialists these concepts, but you did that admirably, so thank you for that, and very encouraging too. This is being filmed, so if you don't want to have what you say on film, don't say anything. Who'd like to go first? Yeah, gentleman over here. There's a mic.
Why is the meningitis seasonal?
I believe it's due to, it's thought to be due to the winds that come across the Sahara. This is the story I'm familiar with. This is my understanding of it. I have not looked up the academic papers to show that it's definitely related to this, but it is related to the seasonal winds that come across the Sahara. We know that the carriage of meningococcus is related to the health of the epithelium, the lining of the throat. That's why smoking is bad for you, and you're more likely to carry the meningococcus, and you're more likely to get sick if the lining of the nasopharynx is damaged. So that's my understanding of why. As I say, I can't quote chapter and verse on academic papers that have proven that, but that's what I've always understood it to be.
Gentleman over here in the front.
Has there ever been a precedent for rolling out a vaccine in sort of larger scale when it's only had 30% efficacy, such as the RTSS? And would that have, negative effects perhaps on having a large number of people vaccinated? It might mean that you kind of decrease the amount of trust that people have in vaccines if they see that it doesn't necessarily have the desired effect.
What a good question. There's certainly been precedents of vaccines that have been rolled out with no efficacy. It's fascinating when you go into the history. And for example, in the 1960s, there was an inactivated measles vaccine that was used, and given to about 1 million people in America, that turned out to not only not work, but actually if you then came into contact with the measles virus afterwards, you developed an exaggerated immune response and became more unwell with it. So, I've given the rosy picture here. What I haven't included is that, and there is a long history of vaccine disasters, and that's one of them. There was hundreds of thousands of US soldiers infected with a hepatitis B virus from a yellow fever vaccine. Disasters that have been there. So that's why it's so important, just as you say, to get it right and to make sure you're not doing any harm. Now, there's no suggestion, I'm not saying that this would harm, it's 30% effective, that's evident. We'll wait the results of the bigger clinical trials to see how that goes. But it's a good point to make that could you potentially undermine a trust in a vaccine program by introducing a vaccine where a significant proportion, what did we say, about 30% of the kids that have had the vaccine are going to get malaria. And saying, well, they've had the vaccine, why is that? We're so used to vaccines being so effective. If you get the measles vaccine, especially if you get 2 doses, which is important, you don't get measles. It's incredibly rare. So there are precedents for using vaccines that aren't 100% effective. There are unfortunately precedents for using vaccines that are not effective at all. Have we knowingly introduced a vaccine that's only about 30% effective? I can't think of anything off the top of my head. One parallel might be for the pneumococcus that I've been telling you about. Pneumococcus is a bacteria that, as I've mentioned, can cause pneumonia, meningitis, and septicemia. There are over 100 serotypes of pneumococcus. The vaccine that was originally introduced in 1999 in America had 7 serotypes. So in the US, it was going to cover about 90% of disease. But when you looked at the same distribution of serotypes in sub-Saharan Africa, it was only covering around 50%. at most of disease, much lower. But 50% of hundreds of thousands of sickness is still better than 90% of a much smaller disease load. So I would say the pneumococcal vaccine would be one example where it has been introduced knowing you're not going to prevent all pneumococcal disease, but you are going to prevent an awful lot of it. One difference there might be that pneumococcus, you don't know it's there until you look for it. Malaria is usually quite obvious. The tests you need to do aren't complicated. Pneumococcus is, if you have a child with pneumonia, you don't actually know whether it's due to pneumococcus or some other bacteria. So with the vaccine failures, if you want to call them that, wouldn't be quite as obvious. So you wouldn't have quite the same effects there.
Yeah.
Thank you. So we've seen this wonderful progress of this 30% or so reduction in malaria deaths over the last 10, 15 years, largely due to bed nets into therapies. Given insecticide resistance to the pesticides, and also given sort of artemisinin resistance, which is emerging in lots of places.
Yeah.
Also with the Ebola crisis, taking a lot of money and healthcare out of malaria, I'm sure in certain areas. Do you think this trend can continue, and what can we do to try and keep on the path that we're going down?
The trend continuum, yes, I guess that is that challenge, isn't it? And it certainly looks encouraging in terms of, there's been no tailing off from this. The artemisinin resistance, you mentioned, is really important in Cambodia, and they're trying to control the use of artemisinin so that you only use it when you need it in that area to try and reduce its uptake, which is an important intervention. Look, I would love a vaccine. Yeah, exactly. You would love to have an effective vaccine because that's going to overcome the issue of resistance to artemisinin and obviously the resistance of the Anopheles mosquito to the insecticides. Yeah. And that's why I think there's still so much work going into malaria vaccines. It is HIV, TB, malaria. They're still the big three in terms of the diseases you'd like to have good vaccines for.
Yeah, woman over here.
When you speak to parents of children in the UK, in Oxford, who've got vaccine-preventable diseases that the parents didn't vaccinate against, what's your most successful argument? Have you ever changed a parent's mind who didn't want to vaccinate?
By the time, I guess the key decision you have before then is the consultation in outpatients when they haven't wanted the vaccine before the child gets sick. Yes. Ideally, you do it before then. I have, at St Mary's, I do remember the father of a child that had measles, who was very sick of people telling him he should have had his child immunised, and he well and truly agreed that was the case. But yeah, so usually by that point they get it. So we've got reasonably good uptakes. We don't, in the UK, I think we can exaggerate the problem, the extent of the problem. It is around 95%, for 90-95% for most ones. Measles is very important to have very high uptake because you can, in the absence of that, you can build up a cohort over time of a vulnerable population, and that's why we're seeing outbreaks in Wales, Swansea. Knock-on effect of the Wakefield disaster from 10, 15 years ago. They remained susceptible, and it all came out. So in terms of what the best argument is, I think you've just got to focus on saying, well, this is the illness, this is why it's serious, and to go back to the basics. One of the most common concerns that you hear about immunisation schedule, and I've just shown you the immunisation schedule, and I'm waiting for someone to say, surely they're getting too many vaccines, they're going to have their immune system overloaded, doctor.
Sorry about that.
Am I meant to do something dramatic now? No? Yeah, that's right. Hidden in there was an important change that I didn't discuss. The whooping cough vaccine that we give now is called an acellular vaccine. This becomes relevant, bear with me. It's called an acellular vaccine. So we take it's either 3 or 5 key proteins from the cell surface and use them in the vaccine. So it's 3 or 5 antigens. The immune system doesn't see a bacteria, it sees the individual antigens. The vaccine that was used up until 2004 was called a whole cell vaccine. So they just took the whole pertussis bacteria, killed it, inactivated it, put it in the vaccine. That had 3,000 antigens. So I think that's actually quite a potent argument to say, look, until 2004, you're saying there's too many vaccines. Until 2004, your body was seeing over 3,000 antigens in the immune schedule, and now it's actually around 20, 25, something like that. It's actually a massive reduction in the immune stimulation that's being used. It's much more targeted immunisation that's being used now. The whooping cough one, as you might have been aware, in the late 70s, there was as much concern about measles and autism as there were 10 years ago. In the late 70s, there was a lot of concern about the whooping cough vaccine and seizures and brain damage. That was not proven. And the concern in that case related to the whole cell pertussis vaccine. So it's also, some parents also find it reassuring to say, actually, we've moved away from that vaccine to a more refined one.
Okay, let's move to the side of the room. Right next there, thanks.
Hello, thanks for the talk. Actually, following on from this question, but on a more broad note, you mentioned earlier in your talk that some vaccines that do work, some countries refuse to include them in their program. Why
Well, so yeah, this is one of the. You could do some fascinating anthropological studies on vaccine scare stories and why they take hold in some countries, not in others. I'll get to answer your question in just a sec. But just as an example, for the measles vaccine scare in the UK, with Andrew Wakefield, it was all about measles and autism. That is the measles vaccine that's causing autism. In America, it wasn't actually about measles vaccine and autism, but they thought it was the thimerosal, which is a preservative in vaccines, that was causing autism. You had this kind of convergence. It must be vaccines causing autism, but two completely different theories as to how that was happening. The MMR was the culprit in the UK. In America, it was all about thimerosal, which is a variant of mercury. You know, there was a legitimate issue here. There was a variant of mercury, and the total exposure to that exceeded the recommended exposure to mercury when he added up all the individual vaccines. And thimerosal has been removed. There's no evidence linking it actually to autism, but it has been removed as a precaution. So, you know, it's interesting how these stories can build up with kind of sound similar, but actually entirely different when you break it down. Now, running alongside that in other parts of the world has been a concern regarding the polio vaccine and a concern that it was that it caused infertility, and especially in the Muslim countries, that this was a plot to, of course, make the Muslim population infertile. So that has been, and there were some imams that were saying that, you know, do not get your child immunised against polio, which has clearly been a disaster, and one of the reasons why it's been so tricky to get on top of that in that area. The whole polio vaccine eradication one is a fascinating story because it will be challenging. In developing countries, they generally use the oral polio vaccine, which is a live vaccine, which is known in about 1 in a million cases to revert to the wild type. So what the virus that's in the vaccine is a weakened form. In about 1 in a million, it can revert to the wild type. So there is a real concern that actually to eradicate measles truly, to eradicate polio truly, you can no longer use that live oral vaccine because there's always a risk while you're using it that you can reintroduce it into the environment. So they'll have to switch to an inactivated vaccine eventually. But you're still going to have people that have been shedding. There are some people that are known to be long-term shedders of the polio virus that are still going to be in the community. So that's actually been quite a challenge. And unlike smallpox, you know, there'll be a long time before people will be able to stop using the polio vaccine.
Carol?
I was really interested to hear about the role of India in developing the African meningitis vaccine. Could you expand a bit on how going to low-income countries for vaccine, middle-income countries for vaccine development might prove a good way forward? Because the cost of vaccine development is always a big issue.
And I think the recent example of the serogroup B meningococcal vaccine, the meningitis B vaccine that I've been talking about, is an interesting one from that point of view. You know, this was a first world, straight down the line pharma company that wanted to develop a vaccine, A, because they could see that there was a need for it, but B, yes, they expected it was going to be profit, make them profit. And there's a real concern actually when there's discrepancy between what price needed to be cost effective versus the price that it's listed for. That actually that's going to be a real challenge, and I think across the industry in general there's been some cooling on vaccines as a way to make money. Coming on to that related issue of, you know, who else is going to make, if you've got a vaccine out there that you really need to make, then who's going to be doing it? And I think that's a fantastic model of taking it out of big pharma and going to alternatives like India. Now what we haven't mentioned at all, because I know very little about it, is the vaccine industry in China. They make huge numbers of vaccines. They're kind of it's not something that we're exposed to here. But there is a massive development and manufacture program going on in China that's really, perhaps, I'm not very aware of, and exactly what the quality controls are and all these other things. The key thing with the SSI in India was that they was done to very high quality controls. It was rigorous WHO standard inspection and maintenance of high standards, but still able to achieve that low dose. So I think it's a fantastic model if it can be replicated. One of the key things about that, though, was that this was a vaccine that people knew what would be needed. It's called a conjugate vaccine. We'd already had a Men-C vaccine, so it's very similar to that. You just needed to adapt it. And I'm oversimplifying it here, but broadly that's what it was. The technology here was not hugely complicated. It's never easy to make a vaccine, but this was not a huge technological challenge. And so that really said, okay, well, this is the kind of really suitable for this kind of model. Whether that's going to apply to other things, I doubt. The malaria vaccine, I doubt it's going to come out of India or a country like that, where you need a massive investment in the kind of the upstream, the research side of things.
Laura, I was going to say that everyone should sing happy birthday to you, but I won't. Happy birthday to you anyway.
Is that another ringtone you've got?
Okay, I actually don't.
No, you do.
I have to have
because it's being
okay,
filmed.
I have to have it since I've been embarrassed and it's my birthday. I was just wondering, coming back to this, I know you said you're not a health economist and it's a slightly unfair question, but in terms of the quality, this sort of £20,000 per quality of this life year thing, rather than think about about the calculation, just think about in the first year of life, what's the value of the interventions that a child receives against that kind of quality figure? Just take an estimate. I'm just interested to know as a parent.
Yeah, I have no idea about that, but it is a really interesting question, doesn't it? And so, firstly, I'm going to answer about 3 questions that you didn't ask, and not the question you did. Is that okay? The quality. Yes, when you put it to parents that there is a disease that kills about 60 children a year, 60 people a year, most of whom are children, but the vaccine is not cost effective. It gives pause for thought. But you tell them that a vaccine that prevents diarrhea, a gastrointestinal illness, and will stop their child going to hospital, basically no one dies from this illness in this country, but actually because of the lost work days, because of the impact on hospitalisation and health costs from hospitalisation, which are significant, that that vaccine is more cost effective than the vaccine that saves lives. When you tell, most parents would actually choose the vaccine that saves lives as the one for their child to receive, rather than the one that's just going to stop them getting sick for hospitalisation, but actually turns out to be more cost effective. So I think that's an interesting aspect of that, is cost effectiveness really the measure that we should be using here? It should be a measure, perhaps not the whole measure. And I know that people who are working in the health economics area in the vaccines also say similar things. It can't be the be all and end all. Second question you didn't ask, I think, is that and also the other impact is, what investment have you made in that child? And I know that is not taken into that calculation there. What is the societal costs? Let's say that this was a teenager or someone at university, as we have here, that's died, that the society has invested 20 years of educating in. So you've invested 20 years in educating, get somebody up to the point that they're about to become a useful taxpayer, and then they become unwell or even die. And I know that they're not taken into account in that equation. And I think that's a really interesting thing. And I know that when you do start to take that into account, vaccines start to become quite a bit more attractive. They're a good investment for society to get children to become taxpayers. Yeah.
Are there any more hands up? Yeah.
I have a question about the anti-vaccination movement. Do you think that we should be worried about this movement, and with respect to which childhood vaccinations in particular, and if there's a difference between countries, in which countries?
Sorry, I didn't catch the name of the movement of this anti-vaccination movement. Yeah, it does differ from country to country, and as I was saying before, it's quite a thing there, quite interesting from that aspect. Again, another example in France, hepatitis B was until recently, I think, a vaccine that was seen to be of concern because of suspected links to multiple sclerosis. which is not something that was very regional there as well. So it does differ from country to country a lot. In terms of how to deal with it, I think it is education. Some countries have mandatory immunisation, which we don't in this country, and I think that's a good thing because I think it can lead itself to people making martyrs of themselves and giving a voice then, that we're being forced to immunise, forced to do this terrible thing to our child. So I'm much more in favour of promotion rather than mandating. In the US, many educational institutions won't take a child unless they've had a full immunisation schedule. Again, that's not something that we've been doing here. I've heard some discussions about it, but I just don't see that being as acceptable. I think that would be fanning the flames of any anti-vaccine movement if you started to mandate. So I'm actually just more about promotion, and I think in general the media have been more responsible about, for example, measles vaccine. They still feel compelled to, on the one hand, give always the classic two-sided thing. Here is a parent for vaccination, here is a parent against vaccination, and giving them equal time, or a scientist for and a scientist against, and giving them equal time. And I guess that bothers me, and that's partly why it can be confusing for the public that, there is obviously equally valid two sides to this argument, when actually that's more often than not the case.
I think the final question over here.
Can I just ask if you can comment about why VZ and Hep B aren't on the routine vaccination schedules in this country?
Yeah, great. So VZ is varicella zoster, the cause of chickenpox, and hepatitis B. The WHO certainly recommends routine immunisation in all countries for hepatitis B, and you've seen there that that's actually been one of the targets. That pentavalent vaccine contains hepatitis B, and that's there to prevent liver cancer. Ultimately, that's the goal there. We actually have quite low rates of hepatitis B in this country, and the rates are higher in certain subpopulations. So we have a program where women are tested for hepatitis B when they're pregnant, and if they are positive, then the baby gets an accelerated course of hepatitis B vaccine that should prevent the risk, which is transmission from the mother to the baby. If that happens, there is a very high likelihood that the baby gets chronic liver disease and gets liver cancer. So that's the goal. They're saying, okay, well actually, if we get this right, we can target it to just the women that are high risk, just the babies that are at high risk, and we will prevent our goal, we will achieve our goal, which is prevention of liver cancer. Always with a targeted immunisation program, it's very susceptible to people forgetting to check the Hep B result on that day or never getting around to getting the vaccine and so on. And so not surprisingly, the uptakes are not brilliant. I know it's being looked at by the JCVI that we talked about. They are looking actively at introducing hepatitis B, and it could be used in combination with the vaccine that's already given, a diphtheria, tetanus, pertussis, polio, hip. You can add Hep B to that. It is being looked at, I know that much. We are the exception. There's about 190 countries that do introduce hepatitis B, do use hepatitis B in their routine immunisation schedule, and we're one of the ones that don't. The second question was varicella zoster, and this is a really interesting one, where I'm a paediatrician. I see kids with chickenpox. Every child I see with chickenpox, the children I see with chickenpox are the ones that are hospitalised with complications of chickenpox. Those complications include skin infections or even bloodstream infections, septicemia, secondary to the chickenpox, also risk of encephalitis and other problems. It kills approximately 10 children a year in this country, chickenpox. And we have a vaccine that is used by America, used by Australia, used by many countries in Europe that we don't use. Why not? The reason it's complicated, the reason actually is because there's a concern that introducing the chickenpox vaccine into a childhood population will increase the risk of shingles in the elderly. Because the varicella vaccine virus is not circulating as much. The shingles is the reactivation of dormant chickenpox virus when your immune system isn't able to contain it anymore. If a child's infected with chickenpox, they carry the chickenpox with them for the rest of their life in their nervous system. When their immune system gets run down, it can get reactivated and comes out as shingles, rash on the skin, which can be very painful and very distressing. When the modelers and the health economists did this, they figured that if you introduce the varicella vaccine into children, your rates of shingles will go up, and actually you will increase the overall burden of disease to the NHS by doing this. Now, I believe that actually this predicted thing this predicted effect has not been seen in America. And so there we are. You know, real life doesn't always follow the mathematical models, of course, as we know, and that's a real challenge. What has been introduced, as you might be aware, into this country is a shingles vaccine. So high dose of the varicella vaccine is given to the elderly at 70 and 79 years of age to try and prevent shingles. To me, instinctively, as a paediatrician, that's not where I would have put the money. But I would say that, wouldn't I? Because I don't see people with shingles. So they've introduced that, and that was cost-effective. Preventing shingles was cost-effective. Preventing chickenpox wasn't.
Great, Matthew. Just before we thank you, I would like to just bring all of your attention to the following seminars. So this is the seminar in our series on health challenges of the 21st century and what's new. Next week, at the same time, we have Dr. David Clifton, who's a bioengineer, talking about mobile health and the technologies and things that are being developed, not least here in the biomedical engineering department. And some of that is just quite extraordinary. So if you're interested in the frontiers of medicine, do come to that. The following week, there's going to be something on food and health, led by Professor Susan Jepp with Tara Garnett and Mike Rayner, and so the series carries on. Do look at the website for that. This coming Monday, we have two events here. At 5 o'clock, we have the Chancellor of the University, Lord Patton, talking on gridlock and train crashes, what happens when the world loses the habit of cooperation. So that's on global governance at 5 o'clock on Monday. You do need to register for that on our website, but we'll have overflow if you can't fit in here. And then after he's finished at 7:30, we have Kate Allen, who's the director of Amnesty International here. That's next Monday evening at 7:30 on the challenge of human rights in the 21st century. Then the following Monday, the 3rd of November, we have Wolfgang Lutz, who's a demographer working on future population projections, impact on education, and there'll be a panel discussion following that. So if you're interested in demography, do come to that. And then the following Monday, if you're interested in globalization and why it creates systemic risks and what we can do about it, come, but you will have to hear me because that's my talk on the 10th of November at 5 o'clock. We also have a panel discussion on the book, Is the Planet Full?, on the 18th of November at 5 o'clock. So a lot happening. I hope you found this as stimulating as I have, and we really do need to thank you, Matthew, for stepping in at the last minute and giving us a fascinating and illuminating talk. Thank you.